Welcome back, everybody. Today's lesson is taken from section 8.3 in your book called Scientific Notation. It's going to be assignments 37, and if there's time we'll do 38 on here as well. Scientific notation is not a new concept to probably everyone. Scientific notation is a way of expressing numbers, usually because some numbers get very, very big and some numbers get very, very small. And it's a way of expressing it without having a whole bunch of zeros or a whole bunch of decimal places. For example, you might get something like 3,760,000 like this. Instead of writing it with all of these extra places, to write this in scientific notation, we take and put a decimal point after the first digit, like that. That's a 3.0, or 3 point, and then we write the significant digits, leaving out all the zeros. So 7, 6, and I don't need to put any of the other zeros. Now we've just basically we've moved this decimal place from where it was right here at the end, and we moved it over this way to put it in this spot. So we basically have moved this decimal place 6 places. So the way to each place we move it is like multiplying by 10 or dividing by 10. So to indicate that, we're going to say times 10, because each time we move it by a power of 10. And we moved it 6 places. 10 to the 6th is 1,000,000. So we moved it this many places, 3.76 times 10 to the 6th. Now notice I'm using an X here for multiply. That's okay. We usually don't use X's for anything but variables, but with scientific notation, we can tell from the context of the problem that this is really scientific notation. Now, notice this number is a big number. And big numbers like this, any number bigger than 1, any number bigger than 1, and this is bigger than 1, will have a positive exponent. Positive exponent. That's because you moved the decimal to the left here, and this number is a big number, has a positive exponent. Now in this chapter we've also taken a look at something with negative exponents. So let's take a look at another number here. How about this one here? By the way, notice how I wrote this decimal value. I've indicated it, instead of using commas up here, oftentimes we write the zeros in groups of 3, and then we can write this number. That's a very small number, and we know it's small because it's less than 1. It's a tiny little decimal, smaller than 1, and yet we follow the same basic rules. Write the number with a decimal point after the first significant digit. That'd be right here. So it's 1.25. And now we moved the decimal from where it is here, this way, to right after the 1. That's 1, 2, 3, 4, 5, 6 places. 6 places, but I moved it the other way. Up here we moved the decimal to the left. Here we're moving the decimal to the right. I moved it 6 places, so I'm going to go times 10 to the negative 6. Now what that means is any number that is smaller than 1, like a number between 1 and 0, a number smaller than 1, is going to have a negative exponent. Negative exponent. And those negative exponents do 2 things. They tell you, 1, you move the decimal the other way, and 2, it tells you that this is a small number, a fractional number. Remember when we talked about negative exponents, we discussed how they created reciprocals. Well, reciprocals are fractions. Like 1 over 10 is a reciprocal of 10. So negative exponents create fractions. This is equal. 10 to the negative 1 is 1 over 10 to the 1. It creates reciprocals. So it creates fractions. So these negative exponents do 2 things. They move the decimal point the other way to the right, and they also tell you got a fractional number. So keep in mind that as you do these two, bigger numbers are going to have positive exponents, some numbers bigger than 1, and numbers smaller than 1 will have negative exponents. Negative. Okay? So keep in mind that negative exponents are for very small numbers. Let's take a look at a couple problems that you might have on tonight's assignment. Alright, let's take a look at this one, these two here. And you can see from this number there's no decimal point showing. If there is no decimal point showing, it's really at the very right end. So it's right here. If you don't see it, it's at the right end. And now we're going to write this in scientific notation. The instructions will say express in scientific notation. So I look back here and I find the first digit, and then I'm going to put a decimal there, and then I'm going to write the other digits up until the last significant digit. So I've got to put this 0 in here and a 5. But after that, everything are zeros. This is going to be times 10 to what? Well, how far did we move the decimal to get it from here to here? From here to here. So 1, 2, 3, 4, 5, 6, 7. I moved it 7 places, and because this number is bigger than 1, this is 10 to the 7th, which is a big number. Okay? Let's do the next one. The significant digit here, the first one is a 7, so we're going to go 7.81 times 10 to what? Well, the decimal had to move 1, 2, 3, 4 places, but this is a small number and I'm going to the other way, so this is a fractional number, so I'm going to put a negative exponent there. It's that simple, and your first assignment is going to be involved turning numbers from standard, these are called standard numbers. You're going to turn a standard number into a scientific notation. Okay? Now the other half of the assignment is to go back the other way. Let's take a look at some. Alright, let's take a look at these two problems here. The instructions are changing now, and it says express each number in standard notation. So they're given to us in scientific notation. You can tell it's scientific notation because it's got 10 to the something. And then you're going to have a number times 10 to the something. I want you to notice this second one here. They didn't put a 0 here, and your book does that, but that's typically not done in science. Science typically puts a number there. They put it like a 0.0. So even though your book will not have a number or a decimal there, typically in science they do write that. Now if we want to put this in standard notation, we're going to have to move this decimal 8 places. Now the question is, do I going to go make this number big or small? Well, positive exponents are going to create big numbers. This is a big number. So I'm going to have to do whatever I need to do to make this number bigger. To make it bigger, if I go to the left, I'm making it smaller. If I go to the right, I'm making it bigger. So I'm going to move the decimal to the right. And just for the moment, I'm going to put a whole bunch of zeros in here. No commas at this point. I need to move this decimal 8 places from where it was. It was here, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Oh, I guessed right. It's the right number of places there. By the way, do not count the zeros. You count the number of places you move it. Let me check that again. Start it here. Go 1, 2, 3, 4, 5, 6, 7, 8. I always use my pencil to kind of indicate my moves. Don't count the digits, you count the moves. So decimal 1, 2, 3, 4, 5, 6, 7, 8. Notice I'm pointing to the spot between the numbers, not the numbers themselves. Alright, now that I have my decimal located, I come back and put the commas in here every 3 spaces. So there's my correct number. I don't need to show this decimal at the end, but I can leave it there. That's not a problem. Now it's a big number. We can tell because it had a positive exponent. And so this number should be a big number there. Okay? Alright, take a look at this number. This number with a negative exponent, it's got to be a smaller number. So I'm going to start with a decimal, and I'm going to have to create enough zeros here. I'm just going to put a bunch of zeros in here for now, see what ends up happening, and then put my number at the end. I don't need the point there, but I'll put it there for now. Alright, the decimal started after the 3, and I need to move it 5 places. So 1, 2, 3, 4, 5. Oh, I've got way too many zeros here. So let's try it again. 1, 2, 3, 4, 5. That's right here. Let me regroup these again. 1, 2, 3. 1, 2, 3, 4, 5. There you go. So 5 places, it's a small number because it has a negative exponent. Here's a little side tip. It does not work up here, but it works down here. Whatever this number is, you're going to have one less number of zeros. It only works on the negative exponents. Doesn't work up here. Don't count the zeros up here, but down here, it's going to be one less. So negative 5 means I'm going to have 4 zeros. 1, 2, 3, 4 zeros. So 1, 2, 3, 4, 5. You might double check every time just to make sure you got the right number of moves. You're checking how far did it move. So there you go. Now again, your book is not going to have this spacing here, but it helps us when we're counting these or checking them to see that they're done right. So let's do a couple more and then I'll cut you loose on that assignment. All right, here's a problem from your homework. It's number 7. The first thing I'm noticing is that there's a negative exponent. That's the thing you should probably check on. Oh, it's got a negative exponent. This is going to be a small number, a tiny number less than 1. So, as I mentioned last time, since it's a negative exponent here, I have an indicator from here how many zeros it's going to include. It's going to be one less than that number. So I'm going to go 0.0000 and then 36, and I'm pretty confident that I've got the right number of moves because I have one less zero than I did the number. Let me count them again. 1, 2, 3, 4, 5 moves. That's the correct number. Let's try another one from that page. All right, let's take a look at this one here. You'll notice that the exponent is 0. Well, this is the easiest kind of problem at all because if you recall, anything to the 0 power is 1. So you're multiplying this by 1. Well, that means you don't move the decimal at all. And that's what this says with the 0 is don't move the decimal. So your answer is simply 6.89 times 1 is 6.89. Anytime you see 10 to the 0 power, the decimal's right where it is. Let's look at another one. All right, let's take a look at this next one here. Notice the exponent is negative, so this is going to be a small number. So I know that at least with the negative exponents, I have an indicator how many zeros I'm going to need. It's going to be one less than this. So I'm going to go 1, 2, 3, 4, 5, 6 zeros. And then I'm going to add my digits here. 1, 2, 4, 3. I ran off the edge there a little bit. But I'm going to double check to make sure that this is correct. So I need to move the decimal 7 places. Here we go. 1, 2, 3, 4, 5, 6, 7. Yeah. Notice again, I'm pointing my pen here between the numbers. Don't count the digits. You count the space, the spots between the numbers. 1, 2, 3, 4, 5, 6, 7. So that's in the right spot. And it's a small number, tiny little decimal, because it was a negative exponent. Let's try one more with a positive exponent. All right, let's take a look at this one. I notice it's got a positive exponent. That means that this number is going to be big. 10 to the 13 power is a very big number. So we're going to move this decimal point 13 places. Now I'm going to need a little bit of extra room, so I'm going to come down below here. And I'm just going to write those digits in there. I'm going to put a bunch of zeros in here at this point. I don't know how many I'm going to need. We'll see here. All right, I'm starting here. See the decimals right here. And I'm going to go 13 counts, 13 places. I'm going to count the spaces between them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. My decimal would be there. I'm going to check it again. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Yep, that's it. The decimal's right here. Notice I'm not counting zeros here. I'm counting the moves of the decimal point. They move 13, so I'm going to put a comma there. 3, 6, 9, 12, and one more is 13. That's exactly right. So you may find a different way of doing it yourself. I don't need to show that decimal point there, but if I do, it's not a problem. All right, let's go the other way and turn from a standard number into scientific here. All right, let's take a look at this one. This is number 10 from the book. Now, the book is doing something here that is kind of the old-fashioned way of doing it. And I don't really like it because it's too hard to count the zeros. You'd have to use the point of your pencil to go in the book and count these. It would be much better if these were in groups of 3. And you can do that with your pencil, but I would probably prefer to write it down with groups of 3 like this. Okay, don't put commas here. See, 3, 3, 3, and one more. So I can see here that I've got 10 zeros. If you count in your book, you carefully count in the book, you'll see that there are 10. Now this is a very small number, so I know I'm going to end up with something times 10 to some negative number. Well, the 4 here, if the decimal is going to go just after the first digit, it'd have to be right there. So this is going to be 4. Your book would just write 4, but I would encourage you to write 4.0 there. And how many places did the decimal have to move? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11, and it's a negative 11 because we have a tiny number. We moved the decimal to the left. So negative exponents give you very small numbers. Let's take a look at that first assignment. All right, your assignment 37 is this one here, and this is all you're going to do is practice scientific notation again. The next assignment, number 38, I think I'm going to go ahead and put it on this video as well. Number 38 talks about working with these. So let's take a look at the material for the next section here. All right, the next section you're going to deal with here in this section in the book here is multiplying two numbers together and dividing two numbers that are both in scientific notation. So there's a couple processes here that we need to think about. First of all, this x means multiply, and when two things are sitting next to each other with a parentheses, this means multiply as well. All four of these things, 1, 2, 3, 4, are getting multiplied together. Well, we know that multiplication is a commutative property, so I can rearrange these any way I want to. Now I'm going to write this down, but you don't have to. I'm going to rearrange this and go 5 times 2.9, 5 times 2.9, and I can multiply those together. And then I can multiply the other two together, 10 to the negative 8 times 10 to the 2. Okay? Now, if I multiply 5 times 2.9, I could use my calculator, and I end up with 14.5. And then this over here, you might want to grab your calculator, but I wouldn't because it's so much easier without it. When you're multiplying together, as you saw from the previous 2 sections ago, when we multiply things with the same base, we add the exponents. So this is going to be 10 to the negative 8 plus 2, or the negative 6. So there would be an answer that has the product of these two. You had to use your calculator to multiply these two guys out here, and you end up with this. Now, this is an okay answer, except it's not really in scientific notation. So this is the second part of this that you're going to have to get used to. Okay, first of all, make sure you add the exponents when you're multiplying. To write this in scientific notation, I need to make the decimal point appear right after the 1, because it needs to appear after the first digit. Well, what did I do to get from here to here? I made this number smaller, okay? If I made this number smaller, then I'm going to have to make this exponent compensate for that by making this bigger. I'm going to compensate, spell it right here, compensate, by making this exponent bigger. I moved the decimal 1 place here to make it smaller, so I'm going to have to move the decimal point here 1 place to make it bigger. Well, what's 1 bigger than negative 5? Be careful here. 1 bigger than negative 5 is negative 6, excuse me. 1 bigger than negative 6 is a negative 5. 5 is bigger than negative 6 on the number line. See, negative 6 is here, and negative 5 is here. One bigger would be negative 5. So I'm compensating. If I have to make this number smaller, I'm going to compensate by making this one bigger. They kind of trade off each other. So this would be the correct answer for that. And we would necessarily make sure that that is written in scientific notation. Now, if it asked us to give this answer in standard form too, we could do that. This is a negative exponent, so I'm going to put some zeros in here. I know I'm going to need 4 zeros, and then I put my digits out here. Let's just double check to see if that's right. Started here, 1, 2, 3, 4, 5 places. That's it. So there's the second way to write that answer. Once it's in standard form, and the one above there is in scientific form. So we're going to practice this compensation a couple more times. Let's look at another one. All right, let's take a look at this problem. This is from your homework. Again, it's multiplying these two together. Now notice I'm going to multiply 2 times 9.4, and I'm not going to write it out here, but I'm multiplying these two together, and I end up with 18.8. I can do that one in my head. 18.8. 2 times 4 is 8. 2 times 9 is 18. 18.8. And the second part here, 10 to the negative 5 plus 10 to the negative 3. I'm adding these two exponents here. So this would be 10 to the negative 8. Now once again, I added 5 and negative 3. Negative 5 and negative 3 is negative 8. Once again, this is not in scientific notation, so we need to put the decimal right after it. Now once again, I've made this number smaller, so I'm going to have to make this one bigger to compensate for that. So what's one bigger than negative 8? Well, it'd be negative 7. One bigger. So I moved one decimal smaller, so I had to compensate by making this one bigger. Now let's write that in scientific, or in the standard number. I know I'm going to need some zeros here. I need 6, which is one less than that. And my number there would be here. Now I'm going to double check that. Decimal 1, 2, 3, 4, 5, 6, 7. That's right. So there are my two answers if I write this in scientific notation and as a standard number. Just remember, you're going to have to compensate to get that in standard form. Check this over again if you need to look at it again. Now let's look at division. All right. Now division, if you recall from a couple of days ago, that when we divide, we don't add the exponents, we subtract. And we're going to subtract the top one minus the bottom one here. So I'm going to use the calculator on this part here. And when I divide that out, I get something like 0.245. I'm not sure if that was a rounded number or not, but that's close enough. 5 goes into 1, a little less than 2, okay. And then this is times 10 to what? Well, 9 minus 5 is 4. So that's 10 to the 4th power. I would divide this out with my calculator, and when you do, you end up with this. Now, this is not in scientific notation again either. So I want that decimal point to appear right after the first digit. Now, what did I just do here? Well, I made this number bigger. I made it bigger by one place, so I've got to make this number smaller. I'm compensating, making up for it. I made this one bigger, so I've got to make this one smaller by 1. This is 10 to the 3. Once again, if I move the decimal 1 here to make this a bigger number, I'd have to compensate by making this one smaller. So there's our answer, and if we needed to write that in standard form, let's see here. I'm going to put some zeros after it maybe. Started here, 1, 2, 3. My decimal goes here. I don't need these places here. Started here, 1, 2, 3. There it is. Now, you could probably figure out how to use your scientific notation on some calculators, but this is, in many ways, it's faster and easier. Let's try another one of these with some negative exponent. All right. I think this is going to be our last example here. We're going to divide, and so you're going to divide these two numbers and you're going to divide these two numbers. Okay, 1.25 divided by 2.5, you could use your calculator, but I can see this is basically a half, so this turns out to be the decimal 0.5. Divide that out. And this is times 10 to what? Well, remember, we are subtracting the exponents here. Top one minus the bottom one. So that's 4 minus a negative 6. Notice there's a double negative on some problems. Here's one that has a double negative because I'm subtracting 4 minus a negative 6. Take a good look at that because the exponents here have to be subtracted when you're dividing. So what's 4 minus a negative 6? Well, that's the same as 4 plus plus. That's to the 10th. So there you go. It's a 10th power. 4 minus a negative 6 is 4 plus a positive 6. So there you go. There's an answer. However, this number is not in scientific notation. I need that decimal point to appear after the first digit. So I'll put a 0 in there. I move that decimal over 1. Well, what did I do? Well, I made this bigger. So to compensate, I'm going to have to make this one smaller. Okay, I'll move this by one place by making it bigger. So I have to move this one place by making it smaller. That would be 10 to the 9th. So there you go. Again, we're going to subtract exponents and make sure if you got double negatives, you pay attention to that. There it is. There it is in scientific notation. If we want to write that in standard form, okay, I'm going to have a bunch of zeros on here, so I'm just going to throw a bunch in here and see if I got enough. I got to move the decimal 9 places. It's a big number because it's a positive exponent, okay? So 1, 2, 3, 4, 5, 6, 7, 8. I need another one. I think I'll go there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 places. That's right. 3, 6, 9 places. There's my number. I don't need to show the decimal point there. So there are two answers, scientific and standard numbers. Just remember that these two are compensating for each other. They're not the same. Whatever you do here, do the opposite over here. Make it smaller. All right, let's take a look at the assignment for tonight. All right, so the second half of this video was devoted to assignment number 38. There it is, page 428. The rest of those problems there. You're going to put these numbers in scientific and standard notation. Please read the instructions so you're doing both. Just a reminder that this sheet here is kind of your guideline on all of this. What did we do on this assignment? Well, you actually did 3A and B. 3A is when you multiply, you add the exponents, and when you divide, you subtract the exponents. So you actually use these two rules to do this assignment. Well, good luck with that. If you have a question, please contact me by giving me an email. I think we're going to get Zoom set up here one of these days, so you can contact me directly with Zoom if you like. We're not sure we're quite there yet, but hopefully we'll get there soon, and you can go out on Canvas and also check out these assignments out there. At the end of this chapter, there will be a test or a quiz, a practice quiz that you're going to need to take, so I can get a feel for how well you're doing on this. Try to keep up with the material every day so that you don't get behind. Take care.